Hi everyone, welcome to the 5.8 notes. These notes are about sketching graphs. And so far what we've been doing this unit is collecting data about one function using another function. But now we're going to collect that data, and we're going to collect so much of that data that we're going to actually be able to graph the other functions given the derivative or the original, etc. And so we're going to do this in two directions. One direction is we are going to sketch the original based on its derivatives, and then the other ones we're going to do the derivative, and based on the derivative we're going to try to get back to the original. We're going to be given the original and we're going to try to get to its derivative. So these are just like some reminders as we do these notes. So if we want to sketch an original function, here's on the right or on the left I have things that we need to know about this original function, and then on the right I have, okay, well, where do we get that information from? So if we want to sketch the original function, we need to know where is it increasing or decreasing, and we collect that information from the first derivative. We also want to know where its relative mins and max are, and we will get that from the first derivative. We will want to know where it's concave up and concave down, and also the inflection points, and both of those pieces of information we get from the second derivative. So we'll start with sketching original functions, but just so you guys know, to go from the derivative back to the original, what you're going to need is you're going to have to tell us where f prime of x equals 0. You're going to have to tell us where f prime of x is positive / negative. You have to tell us where f prime of x is increasing / decreasing if you want to know concavity. And then points of inflection are where f prime of x has a max or min. But again, we're going to get to sketching the derivative from the original later. Okay, so moving on. So our very first function we're going to try to sketch is h of x equals 3x to the 5th power minus 5x cubed plus 3. And this steps over here, a through e, kind of walks us through what we want to do. And then we'll collect all our information that will help us sketch. So the first thing we need to know to graph this function is where is it increasing or decreasing. And like I said before, to do that, you need the first derivative. And so I am going to go ahead, and I'm just going to go ahead and take both derivatives here because I know that I'm going to need them. So I'm just going to go ahead and start there. So this is the first and the second derivative. And the increasing or decreasing, the way that you figure that out is you use the first derivative. And so what you are going to do, like we have been doing, is you're going to set the derivative equal to 0. And then you're going to factor. And I'm noticing here that both of my terms have a 15x squared. So I'm going to pull out 15x squared, and that leaves me with x squared minus 1 behind me, or next, and then x squared minus 1 is a difference of perfect squares, so I'm going to make that x minus 1, x plus 1, and I'm going to set all these sections equal to 0. And so my critical points are then going to be 0, positive 1, and negative 1. And so those are just like the possible places that we could switch from positive to negative on the first derivative, therefore increasing and decreasing, and then again that language vice versa. So I'm going to make my line test. I'm going to do -1, 0, and 1, and then I'm going to plug in numbers in these intervals. So I'm going to start by plugging in positive 2, and I'm just going to imagine what's going to happen. So if I plug in positive 2 here, I get a positive times a positive times a positive. Let's say I plug in a half, positive, negative, positive. So I plug in -1/2, positive, negative, positive, so a minus sign, and then -2 would be positive, negative, negative, so positive. So this is my little line test. I'm going to go ahead and make things smaller now. I'm going to have to keep doing this, but hopefully you have more space on your paper. So now my line test is telling me where's the derivative negative and positive, and I'll translate that information to communicate things about the original function. So based on that, I know that the original function is increasing from negative infinity to -1 and 1 to infinity. And I know that it's decreasing from -1 to 1. So that will help me later. B has to do with finding the extrema. And because of the line test, I've basically done all of my work here. I see here that at -1, we're crossing from positive to negative, and then at 1, we're crossing from negative to positive. And then 0, while it's a critical point, it's not going to be an extrema because there's no swap between positive or negative there. And so I see that I'm going to have a max at -1, and then we'll get to the y value in a second. And I'll have a min at 1. And so we know where the max and min are going to happen, but we also need to know, if we were looking at the original graph, how high or low they would be. And to make a more accurate graph like this is important. And so what I'm going to do is to actually figure out the y value, I'm going to plug -1 and 1 back into the original function. And I'm just going to kind of think about it in my head because these numbers are so small. So this is going to pop out -3 plus 5, which is 2, plus 3, which is 5. And then if I plugged in 1, this would be 3 minus 5, which is -2, plus 3, which is 1. So this is my next set of information that's going to be important when I graph the max and the mins. And then I'm going to put my increasing, decreasing information together too, because that's important. So far we know where our graph is increasing and decreasing. We know where its max and mins at. Now we want to figure out concavity and inflection points. And so for this, we're going to go to our second derivative. So I'm going to do 60x cubed minus 30x equals 0. And then there's a greatest common factor of 30x in both of these. So I'm going to pull out a 30x. I'll be left with 2x squared minus 1. That equals 0. This can't be factored down anymore because it's not a difference of perfect squared. So I'm just going to do 30 equals x. And then 2x squared minus 1 equals 0. This will be, sorry, this should have said 30x equals 0. So I'll get x equals 0, and then to solve this, I'll get 2x squared equals 1, divide 2, and then I saw this kind of on the quiz we were forgetting, but if you square root both sides, or I think on the take-home quiz, if you take the square root of both sides, you'll have the negative and the positive answer. And so I have 3 answers here. I have 0, positive 1/2, and negative 1/2. So these are the possible places where the concavity could switch. Therefore, those are the possible places that there's inflection points. So I'm going to write, oh, also, sorry, this should be, the square root will stay on 2 here. So this should be -1 over the square root of 2, and then 0, and then positive 1 over the square root of 2. And so I'll plug in some numbers now. I'm going to assume that 2 is larger than this number, so I'm going to plug in 2. If I plug in 2 here, this would be a positive number, this would be a positive number, so this would be a positive section. I'm going to plug in I'm going to imagine myself plugging in like a half, because I believe that number 1 divided by the square root of 7 is like 0.707. So I plug in a half here, this would be positive, and then 2 times 1/4, why is this so hard? 2 times 1/4 is 0.5. 0.5 minus 1 is a negative. So I'd have a negative times a positive. So this would be a negative. This would end up being a positive, because if I plugged in, say, a negative, a half, this would be a negative. But this would still be negative, because this is always going to pop out a positive number. And then I'm just going to, let's say if I plugged in -1, negative, and then this would be positive, so it'd be a negative. So those are my intervals. So based on that, I see that the derivative, or the double derivative, the sections where it's positive, that means the original function's concave up, and then whatever sections it's negative, the original function's concave down. So I'm going to go ahead and write concave up from negative, I'm going to go ahead and, it's going to end up being -0.707. I'm going to go ahead and put that number into the calculator. 0 and 0.707 to infinity. And then concave down from negative infinity to negative 0.707 and 0 to 0.707. Okay, so that is my next section that's going to help me. And the last thing I need here is to figure out the inflection points. And again, I've already done most of the work here for that, but I'm just going to go on to D. So based on my line test, inflection points happen when the signs switch. So there's going to be an inflection point here, here, and here. And I just need to figure out their y values now. So I'm going to go ahead and convert these to decimals, just because they're going to be a little easier to work with at this point. and then I'm going to plug these back into the original function. And so I'm going to do that real quick, but I already did it earlier, so I'm just going to tell you what they are. 3, 4.23, and 1.763. But just for the sake of time, I'm going to do that, but I just plugged these numbers back into the original function because I want to see, like, the second derivative tells me, like, again, where it's going to happen, but not exactly where it's going to happen, and that's why I need the original function to tell me that. And that was the last piece of information I need. And now we're going to talk about how do you actually, now that you have all your information collected, how do you actually sketch the graph? So what I will do is I'm going to draw my little coordinate plane over here. Hopefully you have more space than me. I'm sorry if you don't. And I'm just going to kind of make some little dashes. Okay, so I have all the information I need to draw the sketch of this original function. Where I like to start to kind of guide me is I like to start at the points that I'm given. Rather than trying to just like draw increasing, decreasing, and concavity switches, I like to start with the points that the graph gives me. And so this function tells me that there's a max at -1.5 and a min at 1.1. So I'm going to go ahead and start by graphing those 2 points. So -1.5 is going to be right here, and then 1.1 is going to be right here. So I know that when I get to those sections, this one right here is going to be the max, so it's going to look something like this, right? And then this is going to be the min, so it's got to look something like that. And then I also know my inflection points, and so these are my inflection points over here. So -0.74.23, it's going to be kind of hard to sketch, but it'll be like right there. 0.3 is easier, and then 0.707, 1.763 is like right here. So those are a lot of points really close, but actually I'm going to change the colors of my points real quick just so to help you a little bit. So these ones are inflection points. So every time I get to one of those points, the inflection is going to change. And then when I go from here to here, this is a max, so this section has to be decreasing, and then this is a min. So we'll see. Okay, so now I'll go left to right, and I like to start with my increasing part first because I think that's like helpful to start there. So the first section, I'm increasing based on this. I'm increasing until I get to -1. So I'm going to start off increasing, and then my next question is, what's the concavity start going to be? So if I look at -infinity, so a -infinity to 0.707, which is right here, it's going to be concave down. So that's when it looks kind of like a little slide. So let's just go ahead and try our best. It's going to be hard, but I'm going to start by increasing, and I'm concave up, or sorry, I'm concave down. And then once I hit right here, this is an inflection point. So I know that the inflection has to change. And I also know that from -1 to 1, we start decreasing. And just based on how the point is, if that's really a max, it has to start decreasing there. So my inflection is going to change here. And then, another inflection point, which means the inflection again has to change. And then another inflection point, so the inflection has to change again. And then this is a min, so it has to go up after this. And so because of the points that you drew, you don't really, as you actually sketch it, have to think about the increasing, decreasing sections so much. You just have to know, okay, this is a max, so after I get here, it's got to start going down. This is a min, so after I get here, it has to start going up. Inflection point, I have to switch whatever I was doing. I have to switch whatever I was doing. I have to switch. So really the only thing that's really important from like the increasing, decreasing, concave up is to think about how do you start, but then those points that you drew will guide you through the rest. So this one example took so long, but we're going to do at least, I would say 1 or 2 more, and then we'll maybe try to get some done in class because of how long these are going to take. So we'll do this next one, and then we'll try to do this one as well. But again, we might just do some in class based on how long this video is. So going on to the next one, this one says identify, it's the same problem, like pretty much the exact same problem. So we're just going to go ahead and get started. So we know again that we need the derivatives here. So I'll have -24t cubed. And feel free to try this on your own, by the way. I would love for you to try this by yourself. Sorry, this should be cubed. So those are my 2 derivatives, and I know I need those. So I'm going to start with increasing. And, I'm not really going to talk as much here because I kind of talked through the whole one. So I'm just going to do my work. Feel free to pause and stop, and then write down a question if you need a question answered. That just wants to stay big. That's okay. Wait. Erase, erase. Okay, so I've done all the work now. I just want to recognize two things when I go to do this sketch, because there is one thing that we just basically need to pay attention to, and that's that the y values on the maxes and on the max and then this inflection point, -4,261, is huge. And so I'm just going to kind of estimate them. I'm actually not going to draw an axis for the y. I'm just going to do an estimation, but I will draw an axis for the x values because all the x values are small enough to actually fit on a normal graph. And so I'm going to come through and I'm going to start graphing these. So I'm going to start with my max. It's going to be at -6, 437, 3, 4, 5, 6. And I don't know exactly where 430, like that's a huge number. So I'm just going to put it here and I'm going to make sure that it's above my other values, like dramatically. And then that's my only extrema. Then the other points I'm going to have are my inflection point. So 0, 5, I'm just going to put it super, like this is just not going to be proportional and we have to be okay with that. So 0, 5 would be right there. It'd be much lower compared to 261 and 437, but we're just doing a sketch and so it doesn't have to be perfect. And then this is going to be about halfway. So I have a max and I have 2 inflection points and I'm going to use those to guide me as I draw this graph. So I'm going to go over here and this graph is going to start increasing and it's going to increase till 6. And then also this one starts concave down. And so I'm going to increase, I'm going concave down. So once I hit my once I hit my max, it switches from increasing to decreasing, but nothing else switches. Once I hit my concavity or my point of inflection, it's going to switch concavity. So it's going to start looking more like a cup. And then right here, it's going to switch concavity, but it's going to keep going down because we never had a min or like anything else. Yeah, we didn't have a min to make it switch directions. So my graph will look something like that. And again, it's just a sketch, so it doesn't have to be perfect, but you should try to guide yourself as much as you possibly can. And we're going to do one more example. Hopefully this one will not be as long. We will see. It could possibly be just as long. But now, so everything that we've been doing, we've been sketching the original function using pieces of information from the first derivative and the second derivative. But now we want to actually sketch f prime of x, which is the derivative given the graph of f of x. And we're going to sketch it. So when you have like just graphs and you don't have any equations, there's going to be a lot of things that aren't going to be exact because you couldn't figure out exact numbers. And so basically we're just going to try to do this one. It won't take us too long and then we'll do some more in class. And so to gather information, if we want to sketch the derivative, we need to know where it's positive or negative. And I know that we didn't necessarily know that last time exactly, but we didn't have a way of knowing when the original function was positive or negative, but we do know when the derivative is positive and negative because that is where the original function is increasing/decreasing. And so I don't know what all of these points are right here, but I'm actually going to give a bunch of these points some names. I'm going to call this point A. I'm going to go ahead and give this points B, C, D, E, and you're going to see why. So just any points that like kind of stick out to me, that's what I'm going to do, okay? And so if this is the original function, the derivative is positive whenever this original function is increasing. And so this original function is increasing, I guess I'm going to add one more point here. I'm going to call this f. It's increasing over this section. It's increasing from f to b, okay? So it's positive from f to b, and it's actually, I'm just going to stop here.